Coming up on this episode of the IoT Inc. Business Show.
And it tries to limit your planning to shorter time frames and simpler tasks and simpler goals, and allows you to sort of make changes or pivot at any point in time as soon as new information arises, without trying to really lock down your plan of where you're going to be 3 years from now.
Every IoT product, system, or environment I've worked on has pivoted. And I don't mean slight pivots. I'm talking 180 degrees or more. Why? Because the Internet of Things is new. New to the product builder and new to the customer. Because of this newness and the planning fallacy, it's important to take a highly iterative approach to development. In this episode of the IoT Business Show, I speak with Jeff McGee about Agile development and how to use it most effectively when building a new IoT product.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is for business leaders and managers employing the Internet of Things for their business or the business of their customers. I'm your host, Bruce Sinclair, and I interview the industry's leading authorities to find out how they use IoT to improve business and create value. If you like this show, subscribe to it on iTunes and go to iotinc.com to check out my complimentary articles, videos, meetups, and webinars. This is a paid episode, but it's in the same format, packing the same value density you're used to, and it's aligned with what I've been recommending for years. With me today on the IoT Show is Jeff McGee. Jeff is the IoT practice lead at Very, where he's responsible for defining the engineering processes for IoT hardware and software development. He holds an MS in mechanical engineering and computer science and has been leveraging computation to solve problems in the physical world for almost 10 years. Jeff, welcome to the show.
Hey, Bruce. Nice to be here.
So what have you been working on lately? What's been on your desk that you've been focused on?
We have a few projects that are going, reaching sort of production scale with the hardware at this point. And nice. Most recently, I've been taking a step back from the day-to-day implementation and really just on these projects, hopping in and helping where I can with some of the engineers, hardening some of the systems and that sort of thing. So,
Now, how would you break down your time? And then I'll ask you to break down Very's time with respect to an IoT project, and meaning dividing it between, let's just say, between the two, hardware and software development.
Typically, I oversee the general hardware and software on currently all of our projects that we're running in the IoT realm. Mm-hmm. And so what that means is I spend, maybe 6 to 8 hours a week on a given project, just making sure things are tracking well, making sure the engineers that we have who are dedicated to the project aren't blocked by some technical problem that I could help with.
Right.
And then just, making sure all the moving pieces are working together well. In terms of our general engineering team, we try to focus our software engineers on one project at a time. And we've really found that context switching there is very difficult. And I'll get into this later, but we really think that IoT development is much more of a software problem than a hardware problem. Of course, there's hardware, but the main focus we think really has to be on quality software.
Sure.
And our hardware engineers, they divide their time between a few projects because there's things like lead times for prototype runs and stuff like that. So they usually split 2, maybe 3 projects at a time.
Okay, but at a higher level, are you spending 50% of your time on hardware development, 50% on software, or is it a different breakdown?
I would say probably 20% on hardware and 80% on software.
That makes sense, and it emphasizes what you said was important. Now, in terms of hardware development, what does that mean in this particular context?
Yeah, it can mean a lot of things. It varies from project to project. We do everything from custom circuit boards and mechanical enclosures and we have our engineers that work on that. But the other thing that our engineers do a lot of times is work with, if there's an established team that our client has, we'll just sort of oversee the hardware and make sure that it's in a good place for the overall success of the project.
Right.
And working with our firmware and all that sort of stuff. So it could be totally custom stuff, all the way to as little as just like reviewing schematics and, making sure that everything's looking okay from that perspective.
Now, custom stuff, now, is that you're talking about the firmware? Because I'm assuming, I guess, when you say hardware development, you could actually be developing hardware, or you could be choosing hardware, from available OEMs, and then integrating, modifying the firmware, integrating with the software. I'm assuming you're not making sensors. I'm assuming you're not making circuit boards. So maybe just give a little bit more details.
Oh, well, so.
Or maybe I'm wrong.
Yeah, we do actually make circuit boards. I should say we design circuit boards, and then, we have like prototype manufacturers and large scale manufacturers that we engage with project to project, depending on what makes the most sense. We don't go as low as sensor development and like the purest form of sensor development. We're not trying to, invent compounds that, have some voltaic reaction that we can then measure something. We definitely pick those components off the shelf and put them on our circuit boards, et cetera. But, we are currently doing, custom mechanical and electrical PCB design.
Okay. And then you're then choosing, component sets then, or are you actually then individually choosing components? And let's say, whether that's the I/O controller, that's the GP or the MCU, the power, or are you kind of purchasing them as a set generally?
So we'll start with development boards, and so like based around a microcontroller or a larger embedded processor that, you might call a CPU. And we'll start with development boards, and we'll sort of plug and play sensors, and then we'll convert that over to a custom circuit board. So, sometimes we'll use off the shelf solutions, but sometimes it warrants like sort of custom, totally custom circuit boards where, we're picking components that you can buy at a large scale for, pennies, and picking them out individually to build out a full bill of materials for what we need, for that particular application.
Okay. So it sounds like you are kind of picking and choosing at an individual component level versus, as you're aware, there's sets of components, that are being sold into the IoT space. But you're actually picking and choosing and then bringing them all together generally on your own board, then you're saying?
Yeah. Most often, we're not against, I would say, sort of like kits or off the shelf plug and play type hardware, but we really care about the quality of the software, as I've mentioned, and I'll probably continue to mention. And the best way to have full control over the software is to do your custom board most of the time. So.
Okay, and this will be my last hardware question, at least for a little while, because not really our main focus, but it's interesting to have someone that works both in the software and the hardware. And the last question is, from a development environment for developing your firmware, is that Do you have anything custom, or are you using the development kits for the particular, I guess, processing unit? How's that working for Vary?
Yeah, so we leverage a development platform called Platform.io very frequently.
Okay.
That's not our only tool. Some chipsets are not supported by Platform.io, but we really like the way that it allows us to work in an agile manner, more similar to web development. And so we use a lot of chips that are supported by Platform.io. And then we also use, like you mentioned, there's custom SDKs for different chips that the manufacturers release. And that's sort of our, I don't know how to explain it. We don't particularly love that, but we have to deal with it sometimes. And so we, work in those environments when needed, if that makes sense.
No, that makes total sense. All right. Well, why don't we step back and tell everyone listening a little bit about yourself, and in particular, a bit of background, your background in IoT.
Sure. So my first real interaction with technology was really as a mechanical engineering student. And I had a personal epiphany, I would call it, when I realized that you could use software to simulate things in the real world and predict real world events. In my case, really revolving around mechanical engineering and physics and thermodynamics.
Okay.
And a natural extension of that is if you can simulate something, then you can also control the simulation and build control systems within that environment. So, and that's really what I would consider my technical background is in control systems. And I just sort of latched on to that. There's a lot of signal processing and simulation. And since I've been doing this in relatively recent years, machine learning has been big in the control systems space recently. And another part of that, right, is after you've simulated, you interface with real hardware. And I think really IoT sort of is just a natural extension of a lot of this control systems ideas, but rather than traditionally and how I was taught in most of my schooling, where everything sort of runs on one embedded board in an isolated environment, you can start to spread your software out through the network and have a lot more flexibility regarding like what your code base looks like and where it's running and how it can scale and all sorts of things. And so I've just been really continually fascinated by that and how we can build systems that really scale well, are easy to maintain, easy to work on, easy to improve. And that's about it, I guess.
Well, that's not just a little bit. So, I mean, maybe I'll parrot it back to you in slightly different terms, but everyone listening now knows that I am a fanboy of digital twins. Digital twin, as by definition, is going to contain both the data, the metadata, and the raw data, as well as the algorithms. These algorithms, either analytical algorithms or AI, mostly machine learning algorithms, and again, an algorithm and the meta algorithm. And that's where it's interesting, where thermodynamics, where I've seen the work in thermodynamics happen, is at the digital twin level, you may use some sort of finite element mechanism to do the calculations at a high level, just to guide then your statistical simulation of it at a lower level. And then whether you're using an analytical technique or an AI technique to simulate whatever you're simulating. But what you're describing, two things, which I think are super important. One, at least in my terminology, you are describing using the digital twin, although you haven't talked, well, yeah, you did talk about the data. And the second thing is you're utilizing the entire computational surface, and the computational surface can be, right on, excuse me, what we were talking about earlier, that being the computational unit right at the edge. It could be in the cloud, and it can be in between, in the fog, or, the terminology either on the IT network or the OT network. Does that make sense? Is that kind of how you think of things, or is that just different terminologies?
No, that's exactly how I would think of it. I haven't mentioned digital twins directly, but it's something that I'm pretty interested in as well. Nice. Really, the concept of digital twin seems new, or the term is fairly new, but the concept is actually, quite old. And, right. I really gravitated towards that in engineering. I mean, simulation-based control essentially is that.
That's what it is. Yeah, it's a simulation.
Yeah. And so I'm excited about pursuing IoT solutions that leverage digital twins. And that's one of the coolest things I think that's happening right now.
Exactly, and then it sort of goes out. I mean, then if you want to think about the digital twin, in one way, the way you can think about it is a subset of your data strategy, and then the digital twin being a construct, for holding the data, like I was saying, at least in this terminology, the metadata and then the raw data. But it's super powerful, because then if you extend that construct over the topology of the networking, the networking surface, depending, it could be tiny, it could be just a discrete thing, and maybe it's just all within one place. But it's super powerful if you start thinking in those type of terms. And then when you start, and I'll ask you a little bit about security in a moment, but then when you start looking at it from a risk management point of view, and looking at where the attack vectors are, and then what the cost is of those attack vectors, by tying it to both the data strategy being kind of a superset of the digital twin, and again, there could be multiple digital twins, and then mapping that on to the topology. In my view, that's state of the art, man. I don't know a better way of doing it than that.
Yeah, thanks. It's like I said, it's the most exciting thing that I can think of that's happening in the space right now.
Well, let's loop in kind of mostly what our discussion will be about, and that is agile development. So I think for everyone listening, maybe it would just be good to level set. And can you give us your definition? What is agile development, and why is it important to IoT?
Yeah, I would say agile development is really an iterative development process that focuses on fast iterations and really embraces change. Most everyone is familiar with the idea of the planning fallacy. And
why don't you explain it just for everyone?
Sure. Yeah. So the planning fallacy is just this concept that everyone is terrible at planning, especially as things get more complex.
Yes.
And the more complex a thing is, or the further out the time horizon is, the less likely you are to plan efficiently.
Right. And
so the idea of Agile really embraces this concept.
The human deficit in planning.
Exactly. and it tries to limit your planning to shorter time frames and simpler tasks and simpler goals, and allows you to sort of make changes or pivot at any point in time as soon as new information arises, without trying to really, lock down your plan of where you're going to be 3 years from now or something like that.
Or even 3 months from now, maybe.
Right. Yeah.
Right. So maybe can you contrast that with traditional, or I don't know if you would call it waterfall development, and just to kind of hone it in a little bit more, and then maybe, and I can admit there's a few concepts that I'm not entirely familiar with in terms of the wording, but there's a whole vocabulary also. So maybe compare it to traditional development, the traditional development methodology, and then maybe just take us through some of the terminology that's used in agile development, just so our listeners can at least recognize the words.
Sure. Yeah. So traditional development, or waterfall development, as it gets called a lot of the times, especially in the software industry, it gets called waterfall development. It really originated out of manufacturing and construction, where, you know, you're building things that aren't easy to erase, and failure, of course, failure can be expensive in software, but it's even more expensive when you're building a physical thing.
Yeah.
And so the main thing is that you spend a lot of time up front planning every single detail of how this needs to go. Think of like blueprints, detailed blueprints, and P and ID diagrams, and I'm trying to think, you know, all sorts of, you know, all the planning that goes into
both in the in this case, in the hardware. Are you referring mostly to hardware right now?
Yeah, I mean, I would say mostly
from a historic point of view.
Yeah, from a historic point of view, right? And then, so once you've planned out all these details, and then, you know, you spend a lot of time engineering, and then you spend a lot of time testing every single part of this, once it's completed, right? Like, and maybe you can test individual systems, but in general, there's a long QA cycle. And then finally, when everyone decides that this whole thing as a whole is ready and done, then it gets released. And, really, I think the reason, I don't think there's anything wrong with doing things this way when you have very complicated hardware, or, you know, a very complicated machine, or a building, or a skyscraper. You know, those sort of things really do need to be designed this way. But software doesn't really have a lot of those constraints that exist, you know, with complex physical systems. And we can, you know, it's easy to demolish with software a given like section of the product and then just reconstruct it within a few days and, you know, ship the new thing, and there's no problem. And the code base with software sort of always remains in possession of the engineering team. And so you can always make changes to what's out there and always improve it. And when you think about having that ability, you realize that there's a lot more efficient way to work when you have that ability, rather than focusing on like a very set list of requirements and then delivering that exact list of requirements and then, you know, only making changes after that has been delivered.
And so let's loop it into, okay, no, that makes sense. When working with bits rather than atoms, you have a lot more flexibility. But then let's get to the why it's important to IoT part. So in your you know, from your perspective, why is that important?
Yeah, well, I think when you're building anything, it's I mean, especially in a market, it's important to build as fast as you can. And so I think this process, if you can apply it, allows you to move faster than competitors. And the reason I think it applies to IoT is, like I mentioned before, we feel pretty strongly that it's much closer to a software problem than a hardware problem. Really, because if you think about the IoT ecosystem that you're going to have, a proper implementation from the software side will be pretty agnostic to the hardware that's there. You know, of course, as you get closer to the edge, there's going to be more dependency on the hardware. But overall, you can really decouple a lot of the software from a particular piece of hardware, as long as the firmware on that hardware confirms to some API, you know, that you've implemented. Right. And so from that perspective, it lends itself to an iterative approach. And it's easy to start with very cheap software very cheap hardware that you haven't spent a lot of time developing, and then launch a system. And then after your system is launched and working, you can make, more advanced versions of the hardware and slowly swap it out without, really any cost of extra software development if things have been done properly.
Yeah, no, I like that. And, first of all, for sure. I mean, in another perspective is to say, software is where the value is. And, so if we can make obviously the software better, there's more value. But the other thing I would add to what you said is, in my experience, every single IoT project pivots, and it's not even 90-degree pivot. It's like 180-degree pivot or more.
Sure.
And so,
right.
You don't want to be locked. That's why the Agile development process is so, I think, is such a natural fit, because at least in the projects that I've been involved in, and you can, maybe reflect on some of your background and history, but they're always changing. And the big thing is, this is so new. Both the developer and the creator, I should say, and then the customer. Sometimes you just need to see it in action. Sometimes it's just not what you thought it was. So I think, having that ability to pivot really quickly matches the reality of the client-customer relationship, and ultimately is what's required to make it's not a skyscraper like you're saying, but to make a really good IoT product. Do you have any other thoughts on that?
Yeah, I think you're exactly right. It's critical to be able to pivot, and Agile really allows you to do that. A big key to the Agile development cycle is we want to be releasing things that are production ready, but they don't have to be feature complete, because we're allowing ourselves to continually evolve. And so a lot of, sometimes where people get hung up is because it's not feature complete, they think it's not production ready. And we sort of really try to take the viewpoint that we build a single or two or three, a minimal amount of production ready features, and then we deploy that because they are production ready, and we can, like you mentioned, as you need to pivot, we haven't spent a lot of work, developing features that we needed to pivot away from.
Yeah.
And so, you mentioned, different terms in Agile that are important. Mm-hmm. And so I think, this is probably a good time to get into it. The ideal, or the largest sort of planning cycle that we usually typically start with is we call release planning. Mm-hmm. And usually the goal of this planning session is to get some high level requirements for the next 6 to 8 weeks, sort of what should we accomplish in that time frame. It's important to keep in mind while you're doing that, the planning fallacy, but we can at least come up with some ideas and prioritize them and say, these are some good targets for the next 6 to 8 weeks of work. And then, after that, we have each cycle that we go through in this 6 to 8 weeks, we call an iteration. And at our company, we do it once per week. An iteration is a week. Mm-hmm. And, during this iteration, we release one or ideally many production-ready features, and we put them in the hands of the stakeholders. If you're our client, into your hands, or nice. If we're lucky enough to have a user base already, we put it directly into the hands of users. Yep. So we have the point here is that you want to have extremely high confidence in the quality of your work at this time, and that hence the term production-ready, but it doesn't have to be feature complete. And automated testing is a key here. So we do a lot of automated software testing to make sure really that, yes, it's production ready now, but as we go through future iterations and this feature, just becomes a thing that has been done and it's not really at the forefront of everyone's mind, we don't want to spend time still testing it to make sure it works. Nobody should be going through and clicking buttons, making sure that the login works every time. We should have automated tests that do that.
Interesting.
And so these short cycles once a week allow us to adapt really quickly as new information, comes to us through the client or whatever else, or technical problems maybe. We can really quickly adapt where we're focusing our time because we release so quickly in these short cycles.
And where do sprints come in? Why don't you explain that?
So a sprint or an iteration, those can be used interchangeably.
Okay.
You may have heard sprint used, and that's pretty much the same thing. So that's that short cycle, and we during a sprint or an iteration, we have daily stand-ups, which is just like a check-in meeting with usually, or always, I should say, the engineers and the project manager, and then definitely the stakeholder or client is welcome to be in any of those meetings because their input will be valuable. But the critical thing is making sure that the engineers know what they should be working on that day, making sure they're not blocked, and making sure that work is continuing to move forward.
Yeah, and something I found really useful, and it actually came from Ben from your company, and he was kind of comparing how you would build a car. And I don't know, do you know this analogy? And if not, I'll fumble my way through it. But, there's two ways to build a car. Why don't you take us through that?
Yeah, so the idea, and this is the thing, this analogy is a little tricky because it would be a very foolish way to build a car because it's very expensive. But
the concepts make a lot of sense from what you've just been saying.
Yeah, so the idea is that let's think at an abstract level what the purpose of a car is, and it's to get us from point A to point B. Mm-hmm. And the first thing you should do to get you from point A to point B is maybe build a skateboard and see if people are actually getting from point A to point B, see if people actually care about getting from point A to point B. And then if they do, then you can start to get them there faster or with more comfort, with a scooter and then eventually a car. And it's easy to do this with software. And that's sort of the key abstraction that I've been getting at between like the physical world and the software world. That would be very expensive to do in the physical world and maybe foolish, but in the software world, it's actually much cheaper and less risky to do it that way. And that's why, we prefer it.
Yeah. And it kind of organically. So if you take this metaphor of you're building a transportation device and it's going to have wheels because we've agreed it's going to be traveling on sidewalks or it's going to be traveling on roads. And then, like you say, you start with the skateboard and then you iterate on it is this comfortable enough? Nah, I like to sit down. So then you put a seat on it. And does this steer well enough? No, I don't like having to move my body around. So it'd be really great if there's a steering wheel, right? And so then it organically, that's why I like it. And at each time, why I really like it, the metaphor is because it then allows you to then talk to the user of the skateboard or the person that's paying you in this case, to build the skateboard. And then maybe you could then, Jeff, kind of compare that if you could build a car with complex subsystems, right? And do you want to take us through that a little bit, like the engine and the suspension?
Sure. Yeah. So to contrast this with like a waterfall approach, you in building a car, you would have a team designing the engine and a team
super complex engine, right? Yeah.
Yeah, and they start because the client said in the beginning, well, I want a car that competes with a Ferrari, right, and they probably think they do, or they thought they did at the time, and that's what they told you, and you believe them.
Exactly.
And so you went to work. And there's a few things. So in the end, 8 months down the road or longer probably, and many more dollars spent, you present them with your Ferrari competitor, and they're not happy because of of whatever that you didn't interpret or understand from what their initial requirements were, and then you can't really go back at that point without
unless you rebuild the entire engine or rebuild the entire suspension, right?
Right, and that's of course very expensive. So if with software, like I said, you can really leverage the fact that change is relatively easy, and you can sort of push decisions down the road. And normally that has a negative connotation, but you can't the best time to make a decision is when you have the most information that pertains to that decision. So from our perspective, we believe it's important to push a decision to the last responsible moment. And at that point, we have as much information, and we can decide, in the case of a car, we can decide, do we really need this engine at this point in time? Have our users said that they need it? That sort of thing. So
yeah, no, I like it. And what I'll do is I'll ask you to share with me that graphic. There's like a graphic, and I'll put in the show analysis notes for everyone listening, and it'll be a nice way to kind of remind yourself of this discussion. But I think it's fantastic, and I think it's fantastic not only from the perspective of development, like you're talking about, but also from the perspective of business, just in making sure, again, this pivot issue, just making sure that the customer is on board at every single step. And anyway, I love it, and I still use that. I still use that analogy. And is it an analogy or a metaphor? I guess it's someone will have to correct me on that. But let's shift gears a little bit, and I want to talk about just in general using contract manufacturing. So again, going back, to my experience, going to an organization, and there's often going to be talent gaps, and so one talent gap could be exactly what Very offers, and at least, from your perspective, having this very tight integration of hardware, software, or maybe it's just Agile in general. Maybe the organization isn't using Agile. But I guess, what I'd like to hear from you is, if that's the case, the organization decides they want to start developing an IoT project, whatever that may be. The next step is they go, okay, how are we going to do it? Okay, you have to be honest. Everyone here has to be honest with themselves, and that is more in particular, the engineers have to be really honest with their capabilities. And more in particular, it's not that most engineers are going to be able to figure it out at some point, but it's the time dimension that usually bites you in the butt. But let's say the organization has identified the project at a high level. They have identified some talent gaps, and they realize that they need to find a software development partner. What would be a recommendation? Do you have any, best practices, or do you have an approach that you can maybe offer our listeners if they are facing this issue? And I think a lot of them will be at some point if they are working in IoT.
Yeah. I would really suggest that even though you may have a high level plan, I would suggest that your initial engagement with a contractor really be centered around identifying your exact needs and how that contractor can fit in. Every contractor, just like you mentioned, talent gaps, every contractor is going to have their own, talent pool and particular wheelhouse of things that they're good at. So, spend some time, and I believe most contractors offer an engagement like this. I know we do, where, we can sort of do a little bit of research, make sure we identify the hardest potential problems or the blockers that are part of your project, and make sure, we're able to address it and really sort of identify an overall roadmap. Keeping in mind, the planning fallacy always. But, and then once you've done that, if they seem like a good fit it depends. We work time and materials, and just really think about what you need right now from an Agile perspective. Try to move back to this Agile framework that we've been talking about.
Mm-hmm.
Think about the quickest thing that can be released, and how you can build on that iteratively, and try to get that team to focus on that particular problem, so that you'll still have the ability to pivot and all of that.
Yeah, no, that's some really good advice. And in the terminology that a lot of our listeners are probably maybe more familiar with, is I usually call this outcomes. So what are the outcomes? So I think that's great advice of working or identifying your contractors, and when you're starting your selection process, I would add you'd probably want to talk to a couple, and you'd probably want to get their approaches, right, and want to get their budgets. But it's very good advice, as you said, to, I'm just changing the word slightly, but to look at it from an outcome perspective. Don't be prescriptive. Look at what is it that you actually want. And then the MVP, the minimally viable product, is also great advice, because, even though maybe we do go through this Agile development process, but the sample size is only going to be whatever, generally when I do it, when I call this product validation, and ironically, the person that actually I learned this from, his name is Pat Robertson, and he's in Santa Barbara, and he actually coined the term minimally viable product. But generally what we would do is, and you have to pick a frequency or a period that makes the most sense, but just, which really fits nicely with the Agile development process, we'd go to customers. And I think you said that earlier. And then through that iteration, the sample size, we would do 2 meetings just to put a little more flesh on the bones. But for a major customer, we called it market validation, product validation. We would get all of us in a van. This is going to be a representative from management, hardware, software, maybe the biz person or the marketing person, and visit customers, present the product, or excuse me, if you're just testing the idea, then this is going to a bunch of different customers. If you already have a customer for it, you're going to your customer. But at the same time, again, the sample size can only be so big. So the best we could do, just because we have to travel, in the real world, is 2 meetings a day. Maybe we do 5 meetings. That's 10 per iteration step. So even if you're super sophisticated, and I've never done it to this extent, but let's say you had 40 customer meetings, whether it's, different customers or the same customer, that sample size is really small. So you want to get to the absolute minimally viable product, because you want to get it to a larger sample size. And you don't want to go too far, right? You don't want to go too far down the road, as you were saying, because, let's say you had that Ferrari again. You don't want to have to go in there and change the shape of the camshaft or change maybe the number of cylinders, if you're too far along. Does that make sense? Would you,
yeah.
Does that fit your perspective?
Yeah, I think that makes sense. One thing that I would add is, really have a budget in mind. And I mean, it sounds like common sense, but have a budget in mind and trust the consulting partner to really help identify what might be an MVP within that budget. So one of the advantages that the consultant is going to have is that they've seen a lot of these, and they can pick apart features that might be most important, and they can also, really identify what exactly is an MVP, which is sometimes that's a really hard problem to identify what the MVP actually is. And so we at our company, since we've seen a lot of these problems, we can really narrow down and build something that fits within your budget. Of course, if you're willing to compromise, some feature set, right? There has to be, depending on your budget, we may have to cut features, but we can still deliver a full product within, even pretty small budgets.
Okay. Now let's put some context around it. We're talking kind of abstractly. First of all, what type of product? Let's narrow it down to maybe some of the types of projects that you work on, are these generally discrete products, so to speak? Are they systems? Are they environments? Let's first classify that. What are we talking about here when we talk about, let's say, a project? In general, we just choose one now.
Sure. Yeah. So we do a little bit of all of it, but let's say, just for a single product, right? So you have some maybe connected device that you want to put into consumers' hands.
Okay.
And yeah, so we'll start.
Yeah. Okay. So we'll start there. And then, again, I think what we're looking for here, like Jeff said, is you might have to be a little bit flexible on the number of features, but you can't be flexible, at least initially, on your North Star. And so that's going to be the outcomes. What are you trying to do? You might not be able to deliver all the details of that outcome, but that's probably a good place to use, to help you with your North Star. The second thing is you can't have an unrealistic budget in mind. And so I'm not going to be looking for some exact numbers, but I think I want to help everyone listening in terms of, just some bracketing. But, for the discrete products that I've worked on, we're looking at budgets that are not going to be less than, and then you correct me, with your experience that vary, but they're not going to be less than $100,000 to get us to the MVP. And that's before then we have to start really getting some budgets together to get into production. So anywhere between $100,000 to, let's say, again, let's say $700,000 for the process. Again, I just want to give people something a little more concrete that they can kind of hold on to. And of course, you can refine your budget, and you have to be flexible too, because if you go to, let's say, a couple contractors, again, it's all about sample size, and you get 3 different budgets, and then the standard deviation from your budget is like 5 or 6 out there, then probably I didn't budget right. But can you give our listeners, I guess maybe in your experience, it doesn't have to be exact, but maybe bracket a little bit in terms of what a realistic budget would be for a single product, IoT product, let's say a connected product.
Sure. Yeah. So this is, I think your numbers were pretty good, overall. Okay. If you have a product that needs to perform, say, one simple function, a light switch is the easiest thing that I can do. A connected light switch. There's however many of those.
Of course. Yeah.
Yeah. So, if you really pare the feature set down to, we need a light switch. It needs to connect to Wi-Fi, and people need to be able to turn it on and off from their phone.
Right.
That's a very minimal feature set, and I think within the $100,000 range, if we're totally building this from scratch, I think that's within reason. Of course, quantities. You remember we have a variable cost with the quantity of hardware that we start with.
And we're talking about getting to the MVP, right? So this is going to be quantity low, but okay.
Sure. Yeah. So, but in terms of engineering time, 100,000 or maybe less for something like that. One of the things that you should be pushing your consultancy on, and one of the things that we really focus on is if you deploy this minimal viable product, can you build on it? So if you think about the features that the limited feature set that I mentioned, really what's limited, what's been pared down the most is software.
Right.
And if you limit your feature set from that perspective, then you can always grow it as long as your consultancy is really focusing on critical things like over-the-air firmware updates, making sure that, you can always update software on devices. You can always send out new mobile apps. You can always update server code. So, you could launch with, a very reliable app that simply turns the light switch on and off. And then if you get some traction within a year, you could have a light switch that learns the behavior of the user and turns on and off automatically. You could, send out sensors as a separate project that maybe control the lights in other ways. And you can do this all iteratively, as long as your consultancy team is keeping this in mind and working in this way.
No, that's great advice, Jeff. And I guess I would even go further to say that over-the-air updates, for firmware, for other types of software, generally firmware, I would consider that table stakes. So for everyone listening now, that's in there. You have to do it. And I think a very good example. And so we get back to atoms and bits. When we're building the product, it's really hard to change the atoms, specifically if they're in the hands of our customers. And, consider the Tesla Model 3. So the Tesla Model 3, it has thought in advance, and it has all the hardware necessary, the LiDAR, the radar, the different sensing technologies. It has all the hardware necessary to fully autonomously drive, or have the capability to be fully autonomously driven. Now, the software is not there yet, but if you plan ahead, and we can get into details in terms of memory space and computational power and so forth. But if we kind of, blur our eyes a little bit, if we can think ahead, just like Jeff said, if we can think ahead of what we want, where we kind of have to, get a lot of stuff in there initially is in the hardware. So let's make sure we have enough hardware in there, but the software, right? Software is where the value is. Software is what can change, and then you can update. Right? You can update that software. So anything else to add to that, Jeff? I mean, that to me, that's super important.
Yeah, I think that's a great summary. And like you said, over-the-air firmware updates are non-negotiable. You may be able to get away with it on a very small embedded piece of your overall system. So you may have some small chip that's maybe doing low power management type stuff. And it's like being controlled by some larger, more powerful microprocessor. And so you may not update the firmware on that single small chip that's only doing power management, but you should still have the ability to ship new firmware on the complex system, right? The more complex the responsibilities are on your firmware, the more control you want to have over the ability to change or update it all the time.
Yeah. No, I like that. And then, another thing then, I guess we'll just use this as a segue for the last thing I wanted to talk with you about is security and OTA. We need it for security, because there's always going to be this cat and mouse game, with I guess, vulnerabilities. So these type of bugs. And so there's always going to be software patches, again, from the OEM manufacturers of the the components that you're using. So maybe talk a little bit about that, and maybe just give people just your overall philosophy, I guess, in general, for how you think about security and how it should be thought of when looking at a project and working with contractors to get that project done.
Sure. Yeah. So first off, in the embedded world, encryption can sometimes be expensive and difficult. Expensive, like from a computational perspective. So the first thing that we really do is think about the data that is being transmitted or exposed, and whether or not it warrants encryption. Very often it does,
that's right.
But sometimes it doesn't. And
right. Risk management, you take it through a risk management process, right? So go ahead.
That's exactly right. And then the other thing is, really, we focus on the I in IoT, right, is the internet, and we just try to follow internet best practices of security. So,
nice.
Encrypted connections through SSL on the network, and then Bluetooth has built-in encryption mechanisms for when you're paired and transmitting data. You need encryption on your embedded device if you're going to be storing sensitive information there. We almost always try to avoid that anytime we can. So don't store sensitive information in places where other people can get it, even if it is encrypted. Yeah, so just try to design your architecture where the critical information is in a safe place, and then make sure it's also encrypted there. There's a lot of standard web practices for encryption. Don't store passwords in plain text. All of these things that
keys and all the rest of it. Key management.
Right. But. Sure. All of that. A big thing that we like to leverage is called client-side SSL. So SSL, what gives you the HTTPS in your browser, for the less technical, is typically oriented around your computer identifying who the website is. And so you don't want to be tricked by someone impersonating your online banking website.
Right.
But it can work the other way. And in the case of IoT, it's extremely valuable, because we have all these devices that are out there, and our system needs to know if those are devices we trust. Right. And so it's just literally a reversal of the SSL client side. Now it's happening client side, and it allows our server to verify that these devices are ours. And the devices hold private keys that go onto the device at manufacturing time. And the advantage here is there's no sort of password or anything like that, or secret that's stored on a server for all these devices, where if someone gets a hold of them,
go on secrets, yeah.
Right. So the worst case scenario is that someone gets a hold of one device, is somehow able to break the encryption you have on the private key that's on that device, and then they're able to impersonate one device on your infrastructure, which is, that's sort of not likely to happen, and is, that's really where the state of the art is for this security. As long as you're encrypting on the device, that's the minimal, exposure you can have at this point to any sort of nefarious actors. And so we really love to leverage client-side SSL. AWS has support for it, and it allows us to identify our devices without storing secrets, on a server, where if that server gets compromised, someone can impersonate every single device.
Right. Yeah, no, SSL is a great place to start. Foundation for confidentiality, helps with integrity, but we also got to consider just accessibility of the product too. But I think that's great advice. And why don't we? I guess we'll finish this off with what's the latest at Veri? What would you like people to know about Veri, and where can people find out more information?
So our website is veripossible.com. And there's a lot of information there. Our engineers are active bloggers.
Great.
And so you can check out, there's everything from high level. I'm an executive and I need to make decisions regarding IoT, all the way to, nitty gritty engineering type problems and how we solve them. So a lot of great information there. We're really excited about the Nerves project, which I haven't mentioned
what's that?
At this time. So this is an open source, what I would call full stack firmware framework. And it's written in Elixir, which is based on Erlang, and Elixir compiles down and runs in the Erlang VM.
Okay.
And Erlang, for those who may not be familiar, is actually a pretty old technology, battle-tested really in telecom. So it came from Ericsson, I believe.
Okay. No, I'm not familiar, but okay. Mm-hmm. We'll look it up. I'll also put a link to this in the show analysis notes, but go ahead.
Yeah. So definitely throw Erlang and Elixir and Nerves in the show notes.
Okay.
But we're really excited about it's a bit of a paradigm shift in embedded development. Elixir is a high-level language that's gaining popularity on the web, and using it for firmware really allows you to leverage a lot of the same web security type tools that exist in the language already at an embedded level, which sometimes can be tricky. And we're really passionate about it. We're involved in the development of Nerves and Nerves Hub, which is an over-the-air firmware update and device management platform.
Okay.
And we're really excited about the technology as a whole and the capabilities that it gives us. And like I said, the paradigm shift really that it brings to embedded development. And I've given a talk about it, a couple talks about it. I know at least one of them can be found on our website. So definitely check.
Let's point to that as well then. Yeah.
Yep.
No, that's an excellent find. I have to admit that I'm not that familiar with it, but it sounds, I mean, just in general, if you can work on the shoulders of others that have been taking these attack vectors in the back after all these years, then that always makes a lot of sense. And it's and if it's battle tested in terms of Erlang, and if it's already battle tested, I like it. I'm going to investigate it. I'll put all this, everybody, in the show analysis notes. And with that, I'm going to thank you, Jeff. That was great. That was fun.
Yeah, thanks a lot, Bruce. It's been fun.
Okay, that was a useful talk with Jeff from Very. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. I'm your host, Bruce Sinclair. Thank you for listening. Until next time, may your path to IoT business be an agile one.
You have been listening to the IoT Inc. Business Show.